hope you guys are doing well. We got some new stuff to do today. What we're going to be doing today is law of cosines, which I'm sure you guys are like super pumped for. So we got 4, 26, 21. All right, so before solving for things took just law of cosines, but now we're going to learn something a little bit more powerful. Now, remember, with great power comes great responsibility, right? So law of sine is like a shiny Corvette. It is just really nice, right? Law of sines is simple, and it's like the same thing every time. But the problem with law of sines, we started seeing issues, right? When we had multiple triangles and we had issues with, am I finding the acute angle or the big angle? Well, there is a more powerful way to solve those, and that is law of cosines. Now, the downside to it is that law of cosines is a bit of additional work. Okay, so the first thing I want to do for you guys today is prove to you the law of cosines and do that with you. So if you guys have questions, you can let me know. But that is kind of the gist of it. Law of cosines is more powerful. That's not to say it doesn't have flaws. With law of cosine, if you don't solve for the biggest angle, biggest side first, you're in a bad space. Okay. Also, ASS, ambiguous case, is still ambiguous. So law of sines, we don't get out of the ambiguous case, right? ASS, ass triangles are still ass, right? So law of cosine can't fix if you're an ass. God, I love jokes. All right, so what we're gonna do now is I'm gonna do the derivation of this. So to do this derivation, I'm just gonna draw a triangle, and I'm going to label it A, B, and C, and then I'm going to drop down a altitude here and call that H. So this would be little a, this would be little c, this would be little b, and I'm going to call this point D. Sorry, so we have A, B, C, and D, and then we have the corresponding side names. So what I'm going to do, then you're going to want to watch the YouTube video later. Good luck at your game. So what we're going to have is we're going to define law of cosines from this, and hopefully you guys get a pleasant surprise at the end. Okay, so first thing we're going to do is take a look at triangle BCD. So that's this triangle on the left. So if I were to take cosine of angle C, right, cosine would be adjacent over hypotenuse. So that would be segment CD over side A. Okay, so segment CD over side A, right? So cosine is adjacent over hypotenuse. Okay, and then we can rewrite this to say that segment CD is A cosine of C. So that's just manipulating things around, right? Just multiplying by A, we get segment CD equals A cosine of C. Okay. Now, notice that CD is part of side B, right? So so check this out. So CD right here is A cosine of C. You guys with me there? Okay. Then B minus this is going to be this. Oops. A cosine of C. Okay, so if this is A cosine of C, then this is B minus A cosine of C. So I'm just going to write down right here, I'm going to write, hey, segment DA is the same as B minus A cosine of C. Okay, so again, I'm just labeling parts of the triangles in terms of other parts. So we use just definition of cosine to say, hey, this is A cosine of C. And then this side, if this whole length is B, this would be B minus A cosine of C. Okay. All right. We doing okay so far, guys? Okay, so I'm just labeling that bottom side in terms of cosine of c. So the next thing we're going to do, the second thing we're going to do is now we're going to use sine. And you're like, what are you talking about? Sine? We're doing left cosine. Yes, we're going to use sine. So looking at triangle BCD again, I hope we can agree that sine of angle C would equal segment BD over A, right? So it would be opposite over hypotenuse. Okay, or we can rewrite this to say segment BD equals A sine of C. Sorry, my name's in the way. Okay, so again, sine of C is opposite over hypotenuse. Okay, so there is our two things that I just want to, right? So there's our start. So we're just labeling things, right? So that means that H is really A sine of C. Okay. So now things are going to get interesting. Okay, notice how when the altitude comes down, it's a right triangle, which means ABD is a right triangle. So this triangle on the right is a right triangle. So if that's the case, then we would know that segment AB squared is going to equal segment BD squared plus segment DA squared. So that is the hypotenuse squared is going to equal the sum of the legs squared. Okay, so now we're going to substitute in. Are you guys ready? So we don't know what AB is yet, so we're just going to leave that. So we have segment AB squared equals BD. We just found that. That was the sine. So this is going to be A sine of C, quantity squared. And then plus DA is B minus A cosine of C, quantity squared. Are we doing okay so far, guys? Let me know if we're not. Okay. Now, one thing I do want to point out, notice how what is staying consistent is we're talking about angle C. That's super important, okay? So everything that we've done so far is in terms of angle C. So it's perspective of angle C. So you guessed it, we could do all of this again from a different angle, but we're doing this with respects to angle C, because C is for cookie. And that's good enough for me. Okay, so now we're going to expand these two. So I'm going to get AB, segment AB squared equals, so let's expand this. So this is going to be A squared sine squared C, right? Because it's a monomial, right? So we're going to square all the terms. Just a second, I gotta sneeze. Oh gosh, I lost it. Okay, but this one is a binomial. So in a binomial, right, we're going to have B squared minus 2AB cosine of C, and then plus A squared cosine squared of C. Okay, so right, you have your first term squared, your second term squared, and then you have 2 times the 2 multiplied. Right, that's the formula for squaring binomials, right? Okay. Now we're going to rearrange the terms. Okay, so we're going to have segment AB squared equals what do we have here? So we're going to keep the a. So a squared sine squared c. But then plus, we have a squared cosine squared c. And then plus b squared. Oops, I don't know why I wrote this in black. Now I just feel terrible. Cosine c. Okay. Now, the reason why we did this is here we can factor out an a squared. Okay, so we're going to factor out an a squared. So I'm going to have segment AB squared equals, I'm going to have a squared times sine squared c plus cosine squared c. And I hope as soon as you see that, you're like, oh crap, right? Plus b squared minus 2ab cosine c. Well, guys, Pythagorean theorem, what does this equal? That's just 1. And then we have to remember at the very beginning, segment AB is also little c, and this is where we get the law of cosines. Little side c equals a squared plus b squared. Do you guys see how this is right here? This is Pythagorean theorem. Like, hold up, just look at that. Do you guys see how that's Pythagorean theorem? Okay, but what isn't this triangle? This triangle isn't a right triangle. That big triangle is not a right triangle. So remember, Pythagorean theorem only works for right triangles. So what happens when it's not a right triangle? Well, then you have this extra term. And don't trust me, you try it. What happens when angle C is 90 degrees? What's cosine of 90 degrees? 0. So when C is 90 degrees, it's a right triangle. Oh, come on. Some of you got to be like, okay, that's a little cool. Right? That's pretty cool. Guys, we just showed that Pythagorean theorem works for all triangles. You guys aren't impressed? Law of cosine is basically Pythagorean theorem for any non-right triangle. Yeah, that's pretty cool. I mean, right? You have to give it. You have to be like, yeah, that's pretty cool. Okay? So again, when angle C is 90 degrees, right? This goes to 0 because you have a 90-degree triangle. You have a right triangle. Okay? But if it's not a right triangle, this is the factor that makes Pythagorean theorem work, and it's law of cosine. Okay? Now, the problem is, to solve this, how annoying is this going to be? Okay, so first of all, okay. Oh, so many good questions all at once. Okay, so first of all, that was the end of our proof, right? Okay. But the question was, well, so you only did this for C. Well, I did it for C, yeah, because I wanted you guys to see that it's Pythagorean theorem. But check this out. We can do this for any other angle. I can do it for a squared equals b squared plus c squared. Okay, and then minus, and then it's always, these two letters are the two letters here. So b times c times cosine, and then the angle is always opposite from the side. Okay, which means there's going to be one more. So we can do b squared equals a squared plus c squared. Do you guys see how it's the one side and then the other two sides? And then minus, and then it's always 2 times the two sides we used on the inside. So this would be AC, and then cosine, and then this one we're doing B. So this right here is the law of cosine. Okay? And you use whatever one that you want to use. Okay? So now I could prove these other two, but it's the exact same proof. And let's be real, I probably bored the crap out of you until I got to the really cool part, right? Which is, I'm not going to lie, that's basically math in a nutshell. it's pretty boring until you get to the cool part, and then you're just like, what? Right? Like, what? Like, how the heck? Right? That's what math does, right? The process isn't sexy, but the answer is. Okay? And that's when we get really excited. It's like, whoa, what are the implications for this? Okay? So, law of cosine is basically Pythagorean theorem for non-right triangles. Pretty dang cool. Now, Pythagoras didn't know this at the time because he didn't have trigonometry at the time, right? I mean, he was before Jesus, right? So, in this timeline, right, he didn't have this stuff. So that's why Pythagoras thought only whole numbers, right? So anyways. So this didn't come first. This came after someone who was really excited about Pythagoras was like, "Ooh, I can use this trig in new ways." See? And they were just like, "Whoa, I can use this math in a new way to get something cool." Anyways, I'm talking too much. Does this make sense, guys? How are we doing? Are you guys doing okay? You guys still have your heads on? I got so excited I forgot what my lesson was. So let me get my lesson plan open. What was I going to talk about today? All right, law of cosines. We're not doing Huron's formula. That's good to know. 6.2. So I picked out a couple of problems that are good problems to do. Let's go ahead and do that. So we are going to be spending 2 days on this, just like we spent 2 days on law of sines. Do you guys have these written down? Okay, and we have 3, right? Just like we could do with 3 different Pythagorean theorems. Okay, all right. Let's take a look and do some problems with this. So, I should go back to this. Always solve for the biggest side angle first. Okay, and this has to do with calculator stuff. So remember, cosine has unique values from 0 to pi, whereas sine has unique values from negative pi over 2 to positive pi over 2. So because of that, if you solve for the short one first, sine won't work for the second one. You have to do the biggest first because cosine can do the biggest first. You guys remember with sine couldn't do the biggest first. You had to do the acute first, right? Law of cosine has unique values from 0s to 180. That allows us to do the biggest ones, and it turns out you have to do the bigger one first. If you don't do the biggest one first, you're going to end up with problems. Okay? And if I have time, we can talk about that later and why that happens, okay? But that's kind of the basics of it, is because cosine goes from 0 to pi, so it allows us to get obtuse angles in the calculator. Whereas sine has unique values from negative pi over 2 to pi over 2, so it is only going to give us solutions for the first quadrant, or the fourth. Okay. Always solve for the biggest side angle first, okay? Biggest angle is best angle. That used to be a funny joke when I was growing up, but maybe that's not a funny joke anymore. All right. Let's do some stuff. You guys ready? I'm ready for this. Are you ready for this? All right. 8 feet. It's a lot of feet. It's 4 people. 14 feet. Okay, that's also a lot of people. That's 7 people. 19 feet. That's just downright scary because you have an extra foot, and that's when you start looking around you and being like, all right, guys, who brought the extra foot and how did it get here? Now, it doesn't matter how you label your sides, okay? But you should, until you guys get really good at this, label your sides. Because if you don't label your sides, then you won't know what side. It's hard to remember what sides go with what angles, okay? So this is an SSS problem, right? You got 3 given sides, and we have to find the angles. Okay, so I would not, okay, and I'm going to say this again. I would not use law of sines here. And the reason is because this angle right here is going to end up being obtuse. So what's the problem? Law of sine will not give you an obtuse angle. So can I repeat this again? Sine will not give you an obtuse angle. So if you try, right, and we can't use law of sine because we don't know any angles. So there's that too. But again, can I just reiterate this again? Sine will not give you an obtuse angle. So let me give you a hypothetical. Let's say I don't find the biggest angle first. Let's say I find the smallest angle. Okay, so I find angle C. I'm going to get angle C right, no problem. But then you go and you do law of sines to find angle B, and you're going to get angle B wrong because angle B is going to be obtuse and the sine won't give you an obtuse angle. Does that make sense, guys? So if we found angle C first using law of cosine, and then we went to go use law of sines to find angle B because it's shorter and faster, you're in a bad place, okay? So find the biggest angle first. Because the thing is, you don't want to do law of cosines 3 times. It just takes too long, and it's way too much work, okay? So what we're going to do is find biggest angle with law of cosine, and then 2, use law of sine for everything else. And the reason for that, again, guys, is law of sine is quicker, it's faster, it's sexier, it's easier. Okay, whereas law of cosine is our big guns, right? So we big out our big guns to start it, but once we get started, law of sine is going to be the way to go. Okay, so to do this, how do we know what angle is going to be the biggest angle? Well, angle B is going to be the biggest angle because it's across from the biggest side. Biggest side, biggest angle. Smallest side, smallest angle. Middle, middle. Okay, so what we're going to do is we're going to use law of cosine. So I'm going to have B squared. Okay, and then that's going to equal A squared plus C squared minus 2 times A times C times cosine of angle B. And as you can see, this is already a little headache. Now, it's not hard to do, but oh my gosh, we're going to have to do the algebra to get here. Okay, now, I'm going to hit pause for a second. I just realized people probably want me to do this. That's what I did. Now, I have done a lot more math in my life than you guys have. Okay? I have done math, a lot more math, basic math, and I have done a lot more higher level math. And I can tell you right now, the sooner you can solve for everything symbolically and not do things step by step, the better your life is going to be. Now, that's really hard to convince teenagers. And I know I'm knocking you for being young, but I know it's also hard to listen to some white dude wearing a sweatshirt, you know, in a different city and be like, "Oh yeah, I should do that." So I'm going to plead. Solve for everything symbolically first. Then, and this is why we created calculators. Let the calculator do all the arithmetic. Okay? So I am going to refuse. I am not going to touch a calculator until the very end. And the reason for this, guys, is right now we won't have issues. But if you, at any point round, you have just ruined the whole problem. Or if you type something wrong into a calculator, you've just ruined the whole problem. It is so much better to ruin the problem at the end, because then you only have one mistake. But if you make one mistake here and then you keep going and the problem takes a page, you have now just ruined every step after that. You guys see what I'm saying? Do not use your calculator until the very end. Please, please, please. Okay? The only times where that makes sense is if things get really ugly, you might want to do that to simplify, to make it look nicer, just so you're not writing as much. That's the only time I would ever use a calculator in the middle of a problem. Okay? And so what I mean by this is solve for B, but don't compute any values, whether you do it in your head or you do it in a calculator, unless you want to simplify. So this is what I mean. Are you guys ready? I'm going to subtract 14 squared and 8 squared from both sides. Now, you might be thinking, Kraft, can't we do that in a calculator? Sure, I'm not going to, and I don't recommend that you should. Okay, so I'm going to have 19 squared minus 14 squared minus 8 squared equals negative 2 times 14 times 8 times cosine of b. Okay, are you guys ready? I have 4 things being multiplied together. Negative 2 times 14 times 8 times cosine of b. So I'm going to go ahead and I'm going to divide by negative 2 times 14 times 8. So I get 19 squared minus 14 squared minus 8 squared all over negative 2 times 14 times 8. So again, I'm not putting anything into that stupid calculator because I'm not going to make a mistake. Now, in this case, it seems silly because all these numbers would turn out to be pretty nice numbers, right? But if it turns out to be irrational, dear goodness, don't touch it, right? So then what's my very last step? Well, I want to get to angle B. So I take cosine inverse of both sides. Now, I'll show you how to speed up this process in the future because obviously writing this every time is kind of a pain in the butt. But the reason why we're writing it all out this time is because you have to practice. And when you get better, I'll show you what I do. Okay. This right here, we're just going to type into a calculator. Now, the reason why I like this, guys, this right here is our exact answer. Oh my gosh, exact. Why am I spelling? I'm worried so much about not make exact. Oh my gosh. I forgot the C. Oof. Worrying so much about getting the math right. Okay, here we go. So this is our exact answer. Okay, that's our exact answer right here. And we're going to type this into a calculator all at once. And I'm not joking. You got to get good with technology, guys, because math these days, it's all about the tech. So I have inverse cosine. Oh my gosh, and calculators now do this fraction thing so easy. 19 squared minus 14 squared. When I was a student, I had to do parentheses. And oh my gosh, that was so much harder. Negative 2, 14, 8. And then I close the parenthesis. And then I just do a quick double check. Boom, 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 boom. Boom, 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 boom. Of course, I wouldn't. You would. Oh, onward, Stallion! Thank you. I almost forgot. I really hope you're yelling that. It really just it establishes dominance inside the school setting because everyone knows who's the boss. Because you're gonna be like, yeah, that's right. Who controls the stallion? Okay, here we go. So what did I get? Did I hit enter? Oh. So angle B. Do you guys see how this is an obtuse angle? Angle B is approximately 116.801 degrees. Okay, and remember our stallion, right, is still in degrees. Our stallion is still in degrees, so make sure you're in degrees and not radians. Notice how this was obtuse, right? So thank goodness we did this first, because if we had tried law of sines, no bueno. Okay? All right, so then you're going to solve this. We're going to solve this just like we would another one. So like I said, we're going to, now we're going to use law of sines. Okay? So angle B, what did we get? Angle B was 116.801 degrees. So what do you guys want to find next, A or C? Okay, C. C is for cookie. So I'm not going to use law of cosine. I'm just going to use law of sine. So angle C, so sine of C over side C equals and the cool thing is this is still in our calculator, right? Right? 116.801, that's still in our calculator. So I'm going to use that to my advantage. So sine of angle B, which is 116. Okay, but you're going to use angle B. You're not going to use that, okay? So use what's in calculator. And then over, what's side B? 19. Okay? So to solve this, again, I'm going to do everything in one foul swoop. I'm going to multiply by 8. And then I'm going to take sine inverse of both sides. Okay, so I'm going to get C equals sine inverse of sine of B over 19 times 8. Now, if we were in person, we would be using graphing calculators, and I would show you how to store the value B, so you literally could just go alpha B. You know what? See how nice that would be if you could just do alpha B in your calculator? But not everyone has the same calculator, so I'm not going to do that this year. Oh, shoot, I just hit clear. Okay, I still have it, right? So it's my last answer. So since it's my last answer, I can use the answer key. Everyone, how nice would it be? Okay, sine inverse. And then I have sine, and then I can do answer, right? So I can do answer over 19 and then times 8. And I get 22, so I get approximately 22.075. Okay, and then to get my last one, right, I would take, and this is where can I copy and paste in this one? Oh, I can just hit enter again. So I can go, oops, sorry. I'm going to go 180, and then I'm going to go up, and I'm going to go here. I'm going to go 180 minus. I scroll up, I highlight my answer, I hit enter, and then I go minus, and then I scroll up, and I hit enter, and then I can go boom, and that's my exact answer for angle. Oh, shoot. This was angle C. And then I can find my angle A is 41.124. Okay, smallest angle, smallest side, middle angle, middle side. Okay, do you guys see how I did that? Does anybody have questions there? Do you guys see how doing this was a lot easier than doing this? It was less steps. Okay, and we have all the angles. When are we out of here? I'm trying to get you guys kicked out of my class already. Oh, we got 20 minutes. So nice. Okay. So if you guys had questions, this would be a good time to ask. If not, I do want to do one more problem with you guys before I let us practice, okay? Just to guarantee we get through it. Do you know what I mean? Because you've seen me where I get to the end of a lesson and I'm like freaking out because I let you guys have too much time. Okay. Freak out. I hope you guys are doing well. The case numbers in Skagit are getting high, so keep being safe, guys. I don't want to have to read tragic news. I hope you guys are being safe. Also remember, if you guys are 16 or older, you guys are eligible for the vaccine. I think Mandy Dio Sorry, Miss Dio, or McCall. Sorry, she doesn't go by Dio. Miss McCall posted on the at least the senior advisory webpage that Skagit, I think Skagit Fairgrounds are doing a Pfizer vaccination. You guys can sign up for this weekend. I'm just saying, like, I want you guys to get vaccinated because I want you guys to be safe too, right? Like, I just want to take a moment and be like, I love you guys, and I want you guys. You got your first dose, woo! Yeah, I love you guys. I want you and your families to be safe. I do always think of you guys. So, just please be safe. And then that way too, if we all get it, then when we come back in the fall, right? Then we can wink at each other without a mask on. Yay! Okay, let's do this example. Sorry. Here I am caring about my students. That's weird. Shut up, guys. None of this happy talk. Remember, we're here to do math. All right, here we go. So let's go ahead and label this a little bit differently, but still using A, B, and C. We're going to know this is 25 degrees. This is 9, and this is 12. We're going to put units on these. Okay. So again, this is a side angle side. So this is a SAS triangle. Okay. So why did I say that? Because if it was an AS triangle, then it's like grown, right? But then we have to figure out how many solutions, right? So those definitely give us a lot of troubles. So the first thing I'm going to do is I'm going to label the sides in terms of the opposite angle so that it helps us out. Okay. Now, notice here, even in a SAS triangle, we can't use law of sine, right? Because law of sine is easiest. So we always want to look, can we use law of sine first? If we can't use law of sine, then we're going to use law of cosine. Now, pro tip here, what should I solve for first? A side or an angle, and which one? So you guys tell me, what should I solve for first? And why? The correct response is y is not in this problem. Yeah, angle C. Angle C. So first of all, right, look, A is 25. That's acute. So we don't have to worry about A. It's acute. Okay? So out of the two remaining angles, side C is bigger. So angle C is going to be bigger. Now, don't justify it by saying, well, the picture it looks like, right? Remember, the picture is just an aid, right? So we look at the sides. 12 is bigger than 9. Angle A is already acute, so we're going to search for angle C. So that means starting out with side C, and then that's going to be, oh, I can't find angle C first, can I? Because we don't know side A. JK. Okay, so we wanted to solve for C. It doesn't work. So now let's now we're in a dingle hopper. What can we solve for first? I think we have to solve for side A first. So we're gonna have to do side A. Sorry, my inner monologue just went away. Sorry about that. I should always speak out loud when I'm doing math. So I have a squared equals, here above it I can write it out. So I did a squared equals b squared plus c squared minus 2 times b times c times cosine of angle A. So we tried to do the biggest. It didn't work out. I remember now why I chose this problem. That was it. It's like, come on, Kreft, take better prep notes. That's why I chose this problem. Is because you tried to do the biggest, but sometimes you can't do the biggest. And I'll show you what. So if we can't do the biggest, then we're going to have to be really careful about using sine. Don't be too bored, Hayden. We'll get through this lesson together. I appreciate you, homie. I really like your mask, by the way. Good color. All right, so I'm going to go ahead. Now, solving this is really easy. Do you know why it's really easy? You just take the square root of both sides. Okay, but you have to remember it's going to be now it's going to be A equals plus or minus the square root of all that jazz. Now, this is what I mean by shortcut. There's no way you're getting me to rewrite all that jazz. Okay? What a waste of time. Okay? Now, in this situation though, does the negative make sense? No, we're finding the length, right? We're not having a negative length. So it's just going to be the positive. Okay? So I just take my calculator. This is the one instance where law of cosine is actually pretty fast. So I'm going to have the square root. Okay, there we go. The square root of 9 squared plus 12 squared minus 2 times 9 times 12 cosine of 25. Boom. So I get that segment A is approximately 5.407 meters. Okay. Now, this is where I'm going to disagree with the book. And this is another reason why I picked this, because I'm doing a problem out of the book. And I disagree with the book so hard. So the book says go ahead and use law of sine, but then recognize that it should be obtuse and do 180 minus your answer. Well, I think that's hecka confusing, because first of all, that means you're assuming that because it looks like it's obtuse, that it is obtuse. Do you see where I have a problem with that? So this is my advice. If there's the potential that the biggest angle can be obtuse, use law of cosine. Okay? So I'm going to have you guys do that right now. Can you guys use law of cosine to find angle C? So use law of cosine to find angle C. Dude, you know what? It makes an ass out of you and me. That's what assuming does. Okay? So go ahead, use law of cosine. Here, I know some people are going to be in different places here. I'll even help you set it up. Use law of cosine. By the way, a squared is just everything that's in blue. Does that make sense? So if you really wanted to, you could go like this. Oh my gosh, I'm not writing that again though. So hopefully this is in your calculator, right? Because you're going to have to put A here. And then you're going to solve for C. And yeah, this is, it's a crazy calculator problem. So you need to practice using your calculator and getting really good at using your calculator. Now, some really nice calculators have a solver function, so you can type this in and hit solve. I mean, that's what you get for buying a really nice calculator. So, but not all of us have that, so we're going to have to do it the hard way. Here, if I don't put a timer up, I'm going to be impatient. This is probably, how long do you guys think this would take? A minute 30? Let's try it. All right, you guys want to see a little nifty trick to help speed things up? You use substitution. Okay, so I'm going to call this a squared. I'm going to call this b squared. I'm going to call this triangle. And then this is cosine of c. So to do this, I'm going to have, so this is what, c? So I'm going to have c squared minus a squared minus b squared equals triangle cosine of c. Then I'm going to divide both sides by triangle. So I have c squared minus a squared minus b squared over triangle equals cosine of c. And then I'm going to take cosine inverse of both sides. So that's how you speed things up. Now, some people call me lazy, but I like to say I'm efficient. Okay? So do you guys see how solving it symbolically is actually easier than writing out all the numbers? Okay, and as long as you write it down once and you say this is what they are, then I can just type this all into a calculator. So here we go. I'm going to have inverse cosine of, on the top, I'm going to have c squared minus, now a squared is going to be, that's a. So here, I'm going to do parentheses a parentheses squared and then minus b squared. B squared is 9. And then on the bottom, I'm going to have, what's on the bottom? Triangle. So triangle was -2. Don't forget the negative, right? And then a. Oh, shoot. I put it in the wrong spot. Oh no, can I not? Will it not let me? Oh, what a terrible program. Sorry, I don't normally use this calculator. I usually use my graphing calculator where you can copy paste. All right, well, I'm just going to approximate it then. My answer won't be that exact. So I'll just go as far as I can. And then what's B? B is 9. And then I close the parenthesis. Okay. So it takes me longer to type it into my calculator than it does to actually solve it. That's how it should be, right? Because then the calculator punches it out. Okay. So I get angle C is approximately 110.297 degrees. Now, mistakes happen, guys, and until you have ProLux graphing or calculator skills like I do, mistakes are gonna happen. And it's, you know what? Like, I'm not gonna lie, it's frustrating. And it's just frustrating to make mistakes and have to go back and figure out your mistakes. Well, my answer is welcome to Programming 101. You type in a whole bunch of code, it doesn't work. What the heck did you do wrong? Because remember, the calculator will do exactly what you tell it. So this is just practice, practice, practice. Okay. So with that said, we found angle C. So then I would do, okay, 180 minus this minus 25. So then I get angle B, right? So you subtract them. So I get 44.703 degrees. And this was 110.297 degrees. Okay. And then you can use law of sine to find side A. But we're running out of we have enough time. You guys want to find that really quickly? How do you know if it's an obtuse angle? Because if it isn't, you don't need law of cosine. So, hey, I'll tell you what. If you're wrong and you use law of sines, you just pooch the problem. So I would make what I usually do is if I know it's the biggest angle, I use law of cosine. And if I don't know, then I use law of cosine. Does that make sense? Hey, you know what, guys? No, we don't have side A. Or, yeah, I don't think we... Oh, we do have side A. No, we're done. You're totally right. Hey, some of you guys are at school, and I know that it takes a while to pack up to get to your next class. So I'm just going to go ahead and end class and say, I care about you guys. Take care. Have a great day. We'll come back tomorrow and we'll practice more of this, okay?